Welcome to the mechanics of farming. Today, we're cutting to the complexity of the tractor transmission system, the unsung hero that takes the engine's raw power and turn it into real work on the field. This system is the second major component of the tractor, and it's essential for delivering power to the wheels, to the PTO, and to the hydraulic lifting system. From simple direct connections to advanced gear mechanisms, we'll walk you through the different ways tractors transfer power to get the job done. The transmission system doesn't just move power, it controls speed, torque, direction, and power distribution, ensuring the tractor can tackle everything from slow, heavy flowing to quick transport runs. It's made up of key components like the clutch, gearbox, differential, and final drive, all working together to regulate how power flows, shifts, and responds to the operator's commands. What does the transmission system actually do? Simply put, it takes the rotational power generated by the engine and transfer it to the parts that need to move, allowing the tractor to pull loads, drive forward or backward, and operate various implements. It delivers draft power through the wheels, rotary power through the PTO or power takeoff, and lifting power through the hydraulic system, making it essential for every farm operation. This power transfer is achieved using four common methods. We have first is direct coupling. Direct coupling is a simple, rigid connections between shafts that provides nearly 100% efficient power transfer. Next is the belt and pulleys, used where smooth, flexible, and adjustable speed transmission is needed. Another one is the chain and sprockets. It is ideal for transmitting power over longer distances with minimal slip and higher torque. The last common method in tractors is the gears. It allows precise changes in speed, torque, and direction, forming the heart of the tractor's gearbox.
Starting with the simplest method, direct coupling. In this setup, the load is connected directly to the engine using a rigid coupling device, often a flange or sleeve that locks the two shafts together. This method is extremely efficient, delivering 100% transmission efficiency because there are no intermediate components like gears or belts to cause friction or slippage. That means the engine speed and direction of rotations are exactly the same as those of the load. No loss, no lag, no change, just pure direct power transfer. While it's simple and efficient, direct coupling is only used when the engine and the load must always rotate at the same speed. Once connected, there is no flexibility for speed variation or shock absorption, which is why tractors typically use more advanced transmission systems for field operations.
Next, we have the belt and pulleys method. In this setup, two pulleys are connected by a flexible belt that transfers power from the engine to the load. The speed ratio depends on the diameter ratio of the pulleys. A larger driven pulley means slower rotation, while a smaller one increases speed. This means belt systems useful for speed variation and for driving equipment that doesn't require precise torque control. Because belts rely on friction, some slippage is unavoidable. This means the efficiency is less than 100% and performance can decrease as belts wear out, loosen, or get wet. That's why belts require regular maintenance, proper tensioning, cleaning, and occasional replacement. One of the advantages of this system is smooth and quiet operation, making it ideal for light to moderate loads. And with the addition of a third pulley, the belt can be tightened or loosened to act like a clutch, allowing the operator to start, stop, or control the load without disengaging the engine.
Moving on to chain and sprockets. In this method, two sprockets are connected by a roller chain, creating a positive mechanical link between the engine and the load. Just like pulleys, the speed ratio is determined by the sizes of the sprockets, but this time, it's based on the number of teeth each sprocket has. A sprocket with more teeth turns more slowly. One with fewer teeth turns faster. One key features of chain drives is that the direction of rotation stays the same for both sprockets, unlike the last method we'll discuss. This makes chain system reliable when you need consistent direction and timing. Although chain drives are more positive and slip-free compared to belts, the efficiency is still less than 100%. This loss comes from the chain slack, friction between chain links, and sprocket teeth, and the need for lubrication. On the bright side, chain and sprocket systems are durable and capable of transmitting higher torque than belts, making them suitable for heavier loads and tougher agricultural tasks.
Finally, we reach the most common power transmission method found inside a tractor's gearbox. We have the gears. In this setup, two gears are placed side by side so their teeth can mesh and transfer power from one shaft to another. When two external gears mesh, their directions of rotation move opposite to each other, one clockwise and the other counterclockwise. This simple interaction forms the basis of most tractor speed and torque adjustment. The size and number of teeth of each gear are selected based on the required center-to-center distance between shafts and the desired speed output. While efficiency is still less than 100% due to small losses from gear backlash, friction, and lubrication, gear systems remain the most precise and most reliable method of power transmission in tractors. They allow operators to choose the exact speed and torque needed for plowing, hauling, planting, or any field operation. To recap, the tractor transmission system is essential for delivering draft, rotary, and lifting power, the three fundamentals that make a tractor truly functional in the field. We explored 4 different ways this power can be transferred, from the 100% efficient direct coupling method to the more advanced speed and torque controlling gear systems that modern tractors rely on. Understanding how these mechanisms work doesn't just help you operate the tractor, it helps you maintain it better, troubleshoot problems faster, and appreciate the engineering that goes into every pull, lift, and rotation. So, which transmission method do you think is the most reliable? Let us know in the comments below. And of course, don't forget to like, subscribe, and follow for more insightful reports on farm machinery and equipment. Thanks for joining us. We'll see you next time.